Welcome to the dawn of discovery. This slide introduces Decoding the Book of Nature, an exploration into the life of Galileo Galilei and the monumental birth of modern science. Set against a rich backdrop of intricate armillary spheres, celestial coordinates, and geometric proofs, the visual represents the shift from ancient dogma to empirical evidence. Galileo famously argued that the universe is a grand book written in the language of mathematics. Here, those diagrams serve as the very alphabet he used to read the heavens. By merging rigorous calculation with telescopic observation, Galileo didn't just look at the star, he fundamentally rewrote our place within them. Let's dive into the story of the man who taught us how to truly read the cosmos. Our story begins with the foundations of a rebel. Born in 1564, Galileo was the son of Vincenzo, a Lutenist who championed experimental verification over abstract theory. This musical upbringing instilled a crucial belief: mathematical ratios must manifest in the physical world. The epistemological pivot arrived in 1583. While a medical student, Galileo observed a swinging chandelier in the Pisa Cathedral. By using his own pulse as a clock, he discovered the isochronism of the pendulum, the revelation that its swing remains constant regardless of the arc's width. Realizing that nature's laws are uniform and measurable, Galileo made the life-altering choice to abandon medicine for the precision of mathematics. This was the moment the physician became the physicist. To move forward, we must understand what Galileo broke. For 2 millennia, the world rested on the pillars of Aristotle and Ptolemy, a dogma where the earth stood still, the heavens were perfect, and truth was found only in ancient texts. This slide illustrates the seismic paradigm shift. Galileo shattered these notions with empirical reality. He replaced a stationary Earth with heliocentrism and unblemished spheres with rugged, evolving terrains. He proved that gravity acts uniformly regardless of mass and that motion follows a predictable parabolic curve. By shifting the source of truth from theological authority to direct observation and mathematical proof, Galileo didn't just challenge old ideas, he dismantled the very foundation of the ancient world. Welcome to the master's workbench. Galileo wasn't just a dreamer, he was a savvy engineer and a shrewd entrepreneur. In 1597, he developed this mechanical analog calculato, a computer before computers. With specialized scales for arithmetic, geometry, and even metallurgy, it allowed gunners and surveyors to solve complex calculations in seconds. Ever the businessman, Galileo realized the hardware was only half the value. He sold the compass for 50 lire but charged 120 lire for the private lessons and his manual, L'Operazione del Compasso. This text stands as history's first true user manual. Through this device, Galileo proved that mathematics wasn't just for the ivory tower, it was a practical tool for the battlefield, the marketplace, and the future. In 1609, a mere novelty became a weapon of observation. While the Dutch spyglass was a 3 times magnification toy for spotting ships, Galileo saw much further. Through independent deduction and the painstaking craft of grinding his own lenses, he pushed the design to a staggering 20 times power. But the real revolution wasn't just the hardware, it was the direction. While merchants scanned the horizon for profit, Galileo performed the ultimate celestial pivot, aiming his instrument at the night sky. By bringing the distant cosmos into sharp, intimate focus, he turned a simple tool into a scientific portal, proving that the wonders of the universe were no longer out of reach, but distinctly seen as if nearby. In 1610, Galileo released Sidereus Nuncius, a celestial bombshell that effectively shattered 2,000 years of astronomical myth. By aiming his refined telescope upward, he revealed a moon scarred by mountains and craters, proving the heavens were as imperfect as Earth. The discovery of the Medicean stars orbiting Jupiter provided the first absolute proof that Earth wasn't the universe's only center of motion. He then dissolved the cloudy Milky Way into a vast expanse of individual stars and, by 1613, showed a sun blemished by rotating spots. These findings didn't just expand our maps, they demystified the divine. The Aristotelian heavens were gone, replaced by a dynamic, measurable, and breathtakingly vast physical reality. Welcome to the moment that changed everything. For centuries, the Ptolemaic model insisted that Venus remained trapped between Earth and the Sun, meaning it could only ever appear as a crescent. But through his telescope, Galileo saw the impossible, a full Venus, shining in its entirety. This observation provided the definitive proof that the geocentric model was a failure. If Venus could be fully illuminated, it had to be on the far side of the Sun, proving once and for all that it orbits the Sun, not the Earth. By witnessing these phases, Galileo didn't just observe a planet, he delivered the empirical knockout blow to ancient dogma, validating the heliocentric reality and permanently shifting our place in the universe. Step into Galileo's workshop, where he tackled the mystery of motion. While Aristotle insisted heavier objects fell faster, Galileo suspected a universal constant. Since vertical freefall was too rapid for 17th-century timers, he cleverly diluted gravity using a parchment-lined inclined plane to slow the descent. By rolling bronze balls down this ramp and timing them with a precise water clock, he made a staggering discovery, the law of falling bodies. He proved that distance is proportional to the square of elapsed time. Whether a ball was light or heavy, acceleration remained uniform. With this simple wooden ramp, Galileo captured the mathematical pulse of gravity, proving nature follows equations, not ancient assumptions. Witness the elegance of complexity simplified. Here, we dissect the parabola, revealing the hidden mechanics of projectile motion. Galileo realized that a cannonball's flight isn't governed by a single, mysterious impetus, but by the marriage of two independent vectors, the unwavering downward pull of gravitational acceleration and the persistent forward push of constant inertia. The ship-mast thought experiment provides the ultimate proof. An object dropped from a moving vessel doesn't lag behind, it carries the ship's horizontal momentum, falling straight down relative to the observer on deck. By merging these vectors, Galileo proved that motion isn't chaotic, it is a predictable, mathematical dance, resolving the erratic paths of the world into the certain language of geometry. The tension between faith and fact reaches a breaking point. In 1616, the Roman Inquisition silences Galileo, branding heliocentrism as heresy. Yet, Galileo responds with a defiant masterpiece, the Essayer. Here, he presents a manifesto for the scientific method, famously declaring that the universe is a grand book written in the language of mathematics. Its characters are triangles, circles, and geometric figures, without them, the cosmos remains unreadable. By shifting the battleground, Galileo establishes a crucial boundary. Science dictates how the heavens go, while theology teaches how to go to heaven. He isn't just challenging a decree, he is carving out a sovereign space for empirical truth where logic and observation reign supreme. Enter 1632, the year of Galileo's most brilliant masterstroke and his ultimate, fatal error. Published in the People's Italian, the dialogue concerning the two chief world systems was a strategic demolition of the geocentric past. The stage features three distinct voices. Salviati, the sharp, empirical proxy for Galileo himself. Segreto, the witty, open-minded layman representing the reader. Simplicio, the bumbling, simpleton, clinging to ancient dogma. Galileo's genius for logic was unfortunately matched by a lack of political tact. By placing Pope Urban VIII's personal theological arguments into the mouth of the inept Simplicio, he turned a hypothetical discussion into a public mockery. Feeling betrayed, the Pope summoned Galileo to the Inquisition. The dialogue was over, the trial had begun. The gears of history turn with chilling precision in the trial of 1633. Here, we witness the somber confrontation between scientific truth and institutional power. An aging, 70-year-old Galileo is summoned to Rome to face the consequences of his heretical discoveries. The timeline descends from early interrogations to the terrifying decree of threatened torture. On June 22, the tragic climax is reached. Found vehemently suspect of heresy, Galileo is forced to abjure and curse his own life's work. Sentenced to life under house arrest and his dialogue officially banned, the man who mapped the heavens was grounded by the Earth's most rigid dogmas. This was the moment science itself was put on trial. In the quiet twilight of his life, Galileo performs a final, defiant act of genius. Blind, aging, and forbidden by the Inquisition from publishing, he remains confined to his villa. Yet, his mind remains free. His manuscript, Two New Sciences, is secretly smuggled to the Dutch Republic to escape the Church's reach. This masterpiece distills 30 years of labor into two groundbreaking disciplines, kinematics and the strength of materials. By codifying the laws of falling bodies and projectile motion, Galileo provided the direct foundation for Isaac Newton's future triumphs. Stripped of his sight and his telescope, he returned to the purity of mathematical physics, proving that even in total darkness, the light of reason cannot be extinguished. In the shadows of his house arrest in Arcetri, Galileo found his greatest strength not in the stars, but in his daughter, Sister Maria Celeste. She lived within the walls of the San Mateo convent, yet she remained his most devoted confidant and intellectual partner. Her surviving letters reveal a woman who managed his domestic affairs and meticulously proofread his final manuscripts while providing emotional solace during his darkest years. In a final, selfless act of love, she secured permission to perform his court-ordered penance, reciting the penitential psalms, to preserve her father's failing health. Though she died in 1634, they remain eternally united, buried together in the Basilica of Santa Croce, anchored by a bond the Inquisition could never break. We conclude with a legacy that transcends time. Though forced to recant, legend suggests Galileo whispered, "Puris I move," and yet it moves. It took 359 years, but in 1992, the Vatican finally admitted its error. Today, we honor the "father of modern science," as dubbed by Albert Einstein. His name even reached the heavens he charted via the Galileo mission, exploring Jupiter from 1989 to 2003. Galileo proved that truth resides in observation, not dogma. As he famously said, "I have never met a man so ignorant that I couldn't learn something from him." His final verdict remains a guiding principle for all, a reminder that the pursuit of knowledge is an eternal, humble journey.